It comes blowing wild, day or night. It is known in the Atlantic as the god of the wind. This is the hurricane. For centuries, the Chinese have called it Typhoon or Typhoon, the big wind, and it brings with it massive waves and deadly destruction. These are tropical cyclones or typhoons, measuring 1,000 kilometers in diameter, that drift across the Pacific every summer. At sea, they produce enormous waves. When they hit the coast, the lashing winds and rain they bring can destroy everything and leave behind losses worth millions. These storms claim thousands of lives every year, especially in coastal areas. Because typhoons are mercurial, changing in intensity and direction without warning, forecasting their paths is difficult. Something researchers are working frenetically to improve. Toshiyuki Harada is a fisherman in Numazu, just 2 hours drive south of Tokyo. For centuries, his ancestors have crossed the Suruga Bay towards the open sea as he does today. Their existence has always depended on the wind and the weather. The Pacific gives them fish, but it has also brought death and destruction. Harada breeds ornamental fish in this bay. Each of these underwater enclosures holds some 40,000 fish. But these metal frame structures and their contents are at the mercy of intense summer storms when the seas are whipped up into a frenzy. So even as he makes his living off the sea, Harada is always wary of the dangers it presents.
自分ら漁師フィッシャーマンですけども、この漁師の中で、海の神様っていうのを預かってます。っていうのは、あそこにある鳥居、そことあとそこにある祠があるんですけども、大漁祈願、航海安全、無病息災を願った神様で、毎年10月の29日、お祭りをします。
On Numazu's Tokaido Street runs an old railway track that connects to Tokyo. In the old days, the emperors would come to this bay every summer to appreciate its natural beauty. Today, express trains called Shinkansen zip across the city's landscape every minute. The upper floor of the town hall houses the central office of the fire brigade and emergency services. There is some anxiety here today. Commander Hirai and his team have been tracking the cause of their concern for a few hours now. The next typhoon that will hit Numazu. These people are responsible for the 500,000 inhabitants of Numazu. Since forecasts came in from the Typhoon Central Office in Tokyo, they've known to expect an exhausting day and a long night ahead. It's already begun to rain heavily. One emergency services employee inspects the safety measures that have been put in place in the port. Because typhoons don't just bring strong winds and heavy rain. Storm tides and violent waves up to 10 meters high have done extensive damage in the past. This massive concrete gate at the port's entrance will be closed in order to protect the city from the typhoon. In a couple of hours, Typhoon Yagi will sweep the city. A storm tide of 1 to 2 meters in height has been forecast. With the gate closed, the city hopes to ride out this storm that was first spotted brewing some 5 days earlier. Employees at the Typhoon Warning Services in Hong Kong noticed a suspicious configuration of clouds. A small spot on a satellite picture has caught the attention of forecaster Wang Chunwu. He and his colleagues discussed the possibility that this accumulation of clouds could potentially develop into a typhoon. It is a race against time. The earlier the storm hunters discover a typhoon, the better the chances of somewhat predicting its path. To a layperson, the satellite image is just a simple accumulation of clouds. A great deal of experience is needed to understand the actual processes and to recognize the signs that this may result in a typhoon.
Tropical cyclones is a phenomena that encompasses many scales of the atmosphere, from one cloud, this what we call convective clouds, to a circulation that extends to several hundreds of miles or kilometers. And so in order for you to have the interaction among all these different scales of motion of the atmosphere, then you must understand all the different interactions. And I think right now we still have very little knowledge about this, because tropical cyclones form from nothing. They form from a blob of clouds. Now, many times we see all these clouds in the atmosphere. Very few form tropical storms. Why? We don't know why.
While much about typhoons remains a mystery, the fundamental mechanics of how one is formed is known. It is only between May and November that the Pacific is warm enough to give birth to superstorms. The sea needs to be at a temperature of at least 26 degrees Celsius. The warm seawater evaporates and rises. At first, only a few clouds form from the vapor. These pile up and form a mountain of clouds. As these warm, humid air particles rise, they cool down and fall back onto the sea's surface. Heat is emitted in the process. This continuous circulation of air masses creates a suction, which draws in more and more humid air. Then the entire cloud system starts to twist due to the force of the planet's rotation. The storm can now be clearly recognized on satellite pictures. The twisting monster gets its energy from the warm sea and millions of tons of vapor and air. For centuries, Japan has been hit by typhoons without warning. Evidence of the aftermath of the most powerful of these typhoons in modern times, that of 1959 in the Bay of Nagoya, can be seen in the city's museum. At the age of 15, Kunio Fuwa witnessed this devastating typhoon. The experience changed him so much that he founded this museum as a memorial to the victims. He will never forget that Sunday when he was home with the family and the storm suddenly appeared.
雨戸がガタガタやりだしたので、家族みんなでその雨戸を飛ばないように押さえておった瞬間にその雨戸が飛んじゃって、一気に目の前懐中電灯で、見ておったんですけどね、もうすでに、6時過ぎには停電になってましたから、その懐中電灯の明かりで、目の前へ押し寄せてくる、高波というか、水の壁を目の当たりにして、私どもの家族全員が少し高い家の高いところへ逃げたんですが、母親、父親、そして弟が、その水に流されて、いなくなり、僕らも弟と2人、その家の高いところカムイっていうんですが、そこへ捕まってその水の引くのを待っておって2人だけが助かったと。
Typhoon Esewan claimed almost 5,000 lives. Those who lived in wooden houses were defenseless and at the mercy of storm floods. In 1959, only a few had access to TV, radios, or telephones, so there had been no warning about the floods. People were taken by surprise, resulting in the heavy loss of life. Without proper infrastructure, getting supplies to survivors after the disaster was difficult and could only be done by air. The Typhoon Museum today is visited by many who lived through the fury of Typhoon Isewan as children. Isewan would force Japan to introduce new legislation on disaster control. Never was such a thing going to happen again. Massive coastal protection was built as a defense against storm floods. Since then, even the strongest typhoons have not matched the death toll from Isewan. Modern Japan does everything it can to be ready for natural disasters. In this simulation complex at Tokyo's fire department, visitors can experience the brute strength of a typhoon's rage. This artificially created, computer-controlled storm helps teach the public not to underestimate the forces of nature. The Tokyo Fire Brigade hopes it will encourage people to take storm warnings seriously.
それではこれから暴風体験をしていただきます。しっかり手すりを持って、手を外さないように気をつけてください。それではスタートします。
This is a controlled simulation of a storm with 100 km/h winds. Whipped by such a force, the rain lashes against you like a solid wall of water. You have to strain every muscle just to stand up against it. There is water everywhere. You can't see. And you can barely breathe.
はい、終わりです。
In a storm like this, about 500 liters of water per square meter fall. Forecasting the gravity of the rainfall is one of the main challenges typhoon researchers face. In the simulation, people are helpless against the violence of the storm. But here, a flick of a switch will turn it off. Something you cannot do in nature.
それでは最後に風速30メートルを体験していただきます。
Then comes the wind. At 30 meters per second, you'll be hit by a force gushing past you at 110 kilometers per hour. In Europe, this is equivalent to a Force 11 hurricane. But typhoon-wise, this is only the bottom end of the scale. Tropical cyclones can reach 250, some even 300 kilometers per hour. Such a wind would destroy the simulator. A turn in the simulator is likely to leave you breathless, but also reminds you that this is a walk in the park compared to what a monster typhoon could do. Guam is located in the Central Pacific, surrounded by a few small islands. For thousands of kilometers, there is only water, which particularly in typhoon season gets very warm. This is the ideal birthplace for tropical storms, and the reason why it's called the delivery room for storms. Over the years, typhoons have shaped the landscape here. This is Charles Guard, or Chip to his friends. For 30 years, he's observed the formation of typhoons here. With his experience, he can recognize an approaching storm by the color of the water and the height of the waves. Guam is a U.S. territory. The people here are prepared for storms. Every lamppost is of sturdy construction, and the houses are built of solid concrete. Chip is chief forecaster for the U.S. National Weather Service, NOAA, in Guam. Through his work with typhoons, he has developed an instinctive understanding of these natural phenomena. But he's still always learning something new. The lives of the people on the many surrounding islands depend on the expertise of his team. The meteorologists in Guam, too, have become aware of the suspicious mountain of clouds that's already caught the attention of their colleagues in Hong Kong.
NOAA's National Weather Service, Chip speaking. Can I help you?
The showers tend to hold.
Good. How are you?
Meanwhile, a small storm has emerged from the clouds and keeps growing. It seems more and more likely that it will soon reach typhoon-like proportions.
Typhoon up northern part of the Northern Mariana Islands, and yeah. So anyway, it's not going to be a bother to us, but it could pull in some monsoon conditions over us in Saipan later on today and tomorrow. Okay, take care. Bye-bye.
Looks like their best track's pretty good.
How does Chip know that this will become a typhoon and how it will further develop?
Forecasting typhoons out here is a real challenge. The people that do it out here love to do it, and that's why we do it. It's in our blood, you know. And while we're putting out forecasts for them, we're also trying to learn more about typhoons and what makes them click and behave the way they behave. And so Guam is a natural laboratory for studying typhoons.
Weather balloons have long provided meteorologists with critical data. Twice a day, they're released here and simultaneously at other places throughout the Pacific. During the ascent, sensors carried by each balloon measure the current air pressure, temperature, wind speed, and direction. This data is sent out to weather stations around the Pacific to help give timely warning of approaching storms. Research into typhoons began during World War II as a result of the US Navy's loss of ships in the Pacific to these storms that seemingly came out of nowhere. As early as the 1950s, Navy Typhoon hunters took off from Guam on dangerous missions in search of typhoons. While some of these planes never returned, most of these robust aircraft successfully negotiated the battering winds and rain. Once in the midst of a typhoon, sensors would be dropped from these planes. These would transmit the kind of data that scientists still use in typhoon forecasting today.
In the 70s, it was pretty primitive. We didn't have a lot of computers at the time. We did a lot of things manual manner, a lot of grease pencils and paper maps. We got aircraft fixes in from the aircraft. This told us the information about where the typhoon was located and information about its intensity. We plotted that, and we had to determine what the forecast track was going to look like, not from sophisticated computer models, but from very primitive information.
Satellites were used for typhoon forecasting as early as the 1960s. The detection of all emerging typhoons was now possible with geostationary satellites. Besides standard cameras, infrared cameras record heat radiation, so that surface temperatures from clouds, land, and the sea can be determined. The cameras, however, can't see which physical processes are taking place below the uppermost layers of clouds. In the 1990s, the Scatterometer was utilized for the first time. This device transmits microwaves and collects and measures their reflection. This way, the wind speed and direction above the water's surface can be measured. New generation satellites, such as the European METOP satellite, provides typhoon researchers with even more detailed information. They can measure rainfall, wind speed, and the temperature at various altitudes above the surface of the sea. For the first time, the entire structure of the typhoon could be looked at. This is Yokohama, home of JAMSTEC, the Japan Agency for Marine Earth Science and Technology. One of the world's largest computers, the Earth Simulator, is housed in this huge 3,000 square meter hall. It is one of the typhoon researchers' greatest desires to calculate the path of a typhoon using satellites and supercomputers like the Earth simulator. The computer is as protected as a maximum security prison. It can only be viewed through bulletproof glass. Until 2004, this was the world's fastest computer at 35 trillion calculations per second. This supercomputer calculates weather occurrences on Earth, hence also the development of typhoons. All forecasts provided by weather agencies these days are based on computer simulations. These simulations estimate and plot the possible path and intensity of storms. In Japan, while these forecasts have become increasingly more precise over the last few decades, they're still not accurate enough.
まず一つは今までのコンピューターですと実際に一度に扱うデータインフォメーションですねデータ量が少ないためにどうしても例えばその地球を再現しようとすると分解能が非常に粗くなると粗い分解能でやるために分解能の粗さから来る誤差があるそのために予測が正確でなくなるとそして大体人間が住んでるところの方がデータが多い海なんか割合データが少ないとか、そういったような観測データの粗さから来る誤差もあるわけです。だからそういったようなものが起こす誤差というものを少なくするためには観測データをもっともっと正しく分解のをよくするということそれからそのコンピューターが大きくなって一度に取り扱うデータの数が大きくなってそのために分解能が細かくなるそういう2つの大きな条件を満たしてくるようになってくるとだんだんと予測というものが信頼できるようになると。
So will simply feeding supercomputers with more climatic data be enough to create simulations and forecasts of greater accuracy?
Sie haben vielleicht Simulationen vom Earth Simulator gesehen, wo also die Welt gezeigt wird und man also sieht, dass da Strömungen drauf stattfinden, dass sich Wolken bilden und größere Wolkengebilde und sowas. Die sehen ja immer sehr realistisch aus. Aber quantitativ stimmen sie leider überhaupt nicht mit der Realität überein. Und da kann man jetzt zwei verschiedene Schlüsse draus ziehen. A, könnte man schließen, naja gut, wir haben es eben doch noch nicht hoch genug aufgelöst, wir müssen eben noch weiter runtergehen. Aber B, und das ist eher das halte ich eher für richtig, ist, dass die Prozesse tatsächlich nicht richtig beschrieben sind im mathematischen Modell, was diesen Simulationen zugrunde liegt.
By this reckoning, the answer isn't just more data and faster computers. Something else is needed to make typhoon forecasting a more exact science. Scientists need better mathematical models to generate computer simulations that more accurately replicate the behavior of typhoons.
And all these parameters have different values, so we have to weight parameter lists in the corner.
Thus far, scientists have not been able to describe in their models how moving vapor originates from water molecules in the atmosphere or the surface of the sea, or how these microprocesses affect the gigantic cloud formations that eventually become typhoons. But there is currently little being done in this fundamental area of research.
Es geht mehr in Richtung Anwendungsbau und die Theorie, die im Endeffekt das Fundament bildet für den Punkt, den wir in der Vorhersage tropischer Zyklone mittlerweile erreicht haben, die wird heute nicht mehr gemacht. Und die theoretische Forschung, die man heute macht, die wird sich sicherlich erst in 15, 20 Jahren auswirken. Die gibt es aber in dem Maße nicht mehr, weil Theorie eigentlich kaum noch finanziert wird.
Meanwhile, back in Guam, the storm has emerged over the Pacific. It is the 9th one this year. It's been named Yagi. The typhoon hunters have sent their data to the mainframe computers of the US weather services and have received a preliminary forecast about the path of Yagi.
Okay, what do you think?
Now the team needs to assess how the storm will develop. Warnings are sent out to people on the surrounding islands. Around 250,000 people live on Guam and the nearby islands. There are also more than 1 million tourist visitors each year. A special phone service of the US Weather Services provides information about the Typhoon Yagi.
This is the National Weather Service in Guam. Here is the latest marine forecasts. Synopsis for Marianas waters. Tropical storm Solik will move far to the north of Saipan today. Outer rain bands and convergence.
The inhabitants of Guam are lucky this time. The typhoon only hits the neighboring island of Saipan with heavy rains and then moves on.
For the next few days.
Now it is clear. The storm is drifting northwest. The storm hunters in Hong Kong too have kept an eye on Yagi and followed its development. 3 days remain to forecast the typhoon's path and intensity. Is Yagi going to vent its fury in a major city or somewhere in the mountains where it will not cause as much damage? When forecasting a typhoon's path for the subsequent 72 hours, meteorologists' predictions still have a margin of error of 350 kilometers on average.
A small deviation in the angle from which the tropical cyclone is moving can greatly affect, especially over the South China coast, for example. Because the coast is like this, if it deviates by about 10 degrees, it will head towards an entirely different location. It can differ from Hong Kong to Hainan. And then the numerical weather prediction models are not perfect. We have to accept that for the time being. And the models themselves could have some systematic bias, which I'm sure the scientists on the models are working hard on it.
By now, there are many contradictory forecasts about the possible path of the typhoon. Taichung Air Base, Taiwan. In order to determine the prevailing wind direction inside the typhoon, scientists at the DOT-STAR program are planning to fly into the storm and collect data. At this pre-flight meeting, researcher Lin Po-seung explains the objective of the mission to his team. What exactly is this flight expected to achieve?
那原先这几个台风中心的位置呢，各个国家有一些差异。这个是10个国家数值模式的一个预报度哈，有2个数值模式预报是往台湾北部去，那有7个是集中在花莲以南，有一个数值模式预测是通过菲律宾巴士海峡就走掉了。这个 case 会很有意思，就是我们这样的飞行呢，能够决定到底是哪个是对的。
Lin and his researchers will use sensitive sensors to collect data from directly inside the storm. Probes carrying these high-tech sensors will be released through here into the turbulence. Unlike the robust military airplanes used by the Americans to fly through such storms, the Gulfstream Astra is a fast, light business jet. It is equipped with a sturdy satellite radio system which immediately transmits the collected data to the Central Weather Bureau in Taiwan. The aircraft is given a once-over before takeoff. Everything must be in pristine condition in a mission as risky as the one they will soon embark on. Soon after takeoff, Typhoon Yagi is first observed at a distance to obtain an overview of its cloud formation. Lin establishes satellite radio contact via the internet. The pilots must fly at an altitude of almost 12 kilometers to be able to pass over the approaching typhoon. The sensors are being prepared and checked for the last time. When the aircraft dives into the clouds at the edge of Typhoon Yagi, it will encounter wind speeds of up to 150 kilometers per hour, and the team on board are guaranteed a ride that is anything but smooth sailing. Finally, the first sensor is placed in the shaft. The probe is launched exactly over the planned location. During the descent, each sensor records its position, the air pressure, temperature, air humidity, and wind speed inside the typhoon. For 15 minutes, each probe will record data, transmitting it to the plane twice every second before plunging into the sea below. A total of 20 probes are released during this flight. Even as the aircraft is on its journey back to home base, the data collected has already been processed by the weather services of Taipei, and a forecast is being made. Typhoon researchers worldwide can access this data online. The analysis of data collected on this flight shows Yagi is drifting towards northern Taiwan.
今天6小时的飞行呢，我们注意到这个台风呢非常对称的移进我们的目标区，所以我们沿途的飞行就在云的当中啊，从西南角、东南角到东边到北边，整个我们都在云层中的飞行。那甚至在不同地点都发生不同轻度的一个不同等级的乱流。即使我们到了北边，到了日本那覇最北边那一点呢，飞机还遇到一个非常大的一个乱流。这个在卫星云图的资料并没有办法显示，但是对一个飞行器来讲有这样的一个不确定性在。所以我们今天的抛投点呢，许多投落送在云区里面 ，GPS 的接收不是很理想。所以我们原定抛投16个投落送呢，后来我们再增加5个投落送，让整个资料更为完整。
When you see the data and you realize it's indeed very big and intense, before that it is all by estimation or by imagination from the cloud patterns, whatever. But after taking the data, when you see the data, you plot all the profiles of the wind in the 3D, in three-dimensionally, and you see, wow, the storm is really huge and strong.
Taiwan has been repeatedly hit by natural disasters. In the last 60 years, 175 typhoons have come ashore on Taiwanese soil. Amongst them was the devastating superstorm Sepat in 2007. The storm arrived one August evening and raged in Taiwan for only one night. Squalls at more than 250 kilometers per hour caused massive devastation. Heavy rains and tidal waves propelled by the storm flooded many parts of the coast. 2,500 people had to abandon their houses. Traffic came to a standstill, trains immobilized, and flights cancelled. The damage in Taiwan caused by Sepat was estimated at $13 million. The power supply was cut off in many places. 500,000 homes spent much of the night in darkness. While the storm raged outside, the fire department and disaster and rescue services in the region prepared themselves for the challenging tasks ahead. The first reports of the Typhoon Sepat were shown on TV, and storm warnings were broadcast. Over the radio, all units were alerted.
收到。
The heavy rains brought by the storm caused widespread flooding. On the night of the storm, local precipitation was 900 millimeters, 3 times more than the average rainfall for the entire typhoon month of September. The next day, the extent of damages was evident. Many orchards in the mountain region of Nantao were destroyed. Landslides blocked access to villages. The inhabitants were left to fend for themselves. Only later did emergency services manage to reach these mountain villages. Emergency services were operating non-stop. Meanwhile, Typhoon Sepat had moved on to China, where it left a trail of destruction estimated at more than $730 million. 40 people died. The emergency service operations are coordinated by the mayor's office. The damages were reported with careful precision and assistance deployed. Then the task of clearing up the destruction in the mountain villages began. On one main street, Typhoon Sepat had knocked over 21 thick trees like they were matchsticks. Within a few hours, about a half a ton of water per square meter rained down. Heavy machinery was used to clear the entrances to these villages. In many areas, phone lines and electricity supplies were cut off for days. Because of the early warnings put out by Taiwan's weather services, a bigger disaster was averted, with the number of fatalities relatively low. But this time Taiwan is spared. Yagi turns and heads towards Japan. Aircraft flying into the region receive storm warnings and alter their courses to fly around the typhoon. Viewed from a distance, the typhoon's massive buildup of clouds looks deceivingly serene. But in Tokyo, the rains and wind announcing Yagi's arrival have begun. The seasoned Japanese take it in their stride. For them, it is just one of the many summer storms they've encountered. The Typhoon Bureau of the Japanese Meteorological Agency is the nerve center of the operations. New satellite pictures are analyzed and assessments of the typhoon are forwarded to the TV stations. For over 100 years, from the days of the Emperor Meiji, the Japanese have tried to forecast typhoons. But today, even with modern technology, they still do not fully understand the storm that's heading towards their coast. It remains unpredictable. In Japanese culture, human beings are part of nature. Mountains, streams, and even typhoons are considered divine. But their gods are sometimes fallible and commit human mistakes, like being malicious and inscrutable, the very characteristics of typhoons. Kazakami, the god of the wind and the atmosphere, and lord of typhoons, is believed to live in this forest. Toshio Sugiura is the high priest of the Kazakami shrine north of Nagoya. In 1959, Typhoon Isewan devastated this region. These serrated paper strips, called shide, signify this is a sacred place. The priest's helpers prepare the shrine with great devotion. Every year, people pray to Kazakami for less typhoons to come their way. Priest Sugiura believes these prayers are heard. When the big typhoon came in 1959, the inhabitants of the bay who had prayed for their lives at the shrine were said to have been spared. Since then, the shrine and priest Sugira have been famous in the entire region. This ritual prayer stick, adorned with paper strips and small bells, plays an important part when consulting the god of the wind. It is placed near a natural air vent in the cliffs nearby. The number and intensity of typhoons to come over the next year is indicated by how much the paper strips and bells are stirred by the winds.
今までね、僕がこう道に入ってからでもね、やっぱし西湾台風後はそう台風が我に来ないんです。来てもやっぱりそれていくことがね。それで皆さんが余計こう信仰されてね、神様にお願いすると台風もこういうようにそれ行くというようなことが自然の法則ですね、これは。キリスト教にこれやって治るとかいうもんじゃないです、これは。
Many faithful also buy plaques called ofuda. These elicit Kazakami's help to protect their homes during typhoons. Typhoon Yagi now drifts towards central Japan. The town of Numazu is directly in its path. It has been raining for hours, and the water in the bay turns brown. In the harbor, the sea is increasingly rising. Fisherman Harada has prayed to the god of the sea for help. Even before it arrives, Typhoon Yagi's presence is already evident. Harada can do little to protect his fish farm in the bay, but he does what he can to secure his boats. Harada hopes he's done enough. He prays his boats will not be smashed against the docks by the winds and waves, as it happened some years earlier. Soon, the winds will blow at 100 kilometers per hour. A storm tide rising 1 to 2 meters is expected. With his boat secure, Fisherman Harada has another task to undertake, that of a firefighter. Harada and his neighbor have been assigned to the storm guard. They will remain in the fire station on standby all night, ready to be called to attend to any emergency. The latest forecasts for the night are shown on TV. The storm is moving very fast now. It changes direction every hour. Sirens warn the locals of the approaching danger. Then Yagi breaks. First at 160 kilometers an hour above the offshore islands of Izu. It floods streets and destroys power lines. After the rain, the greatest danger is the storm tide. The choppy seas have ripped several boats free from their moorings. At the Numazu Fire Department headquarters, there is a sigh of relief as Yagi changes its direction yet again. A moment ago, it was heading directly towards the town, but it is now turning off towards Tokyo, just a few kilometers to the east. It'll probably brush by the edges of Numazu. All streets around Numazu are already blocked. No vehicle can travel the coastal roads towards Tokyo, and more rain is predicted for the night. TBS is one of Japan's most popular TV channels. Content for the station's 5 o'clock news is being decided upon at the Central Weather Conference. Hiroki Iwasaki coordinates the operations of the studio and monitors the journalists who are covering the storm from different parts of the city. Typhoon Yagi is the day's big story. Half the news program will carry reports pertaining to the storm. This is Masamitsu Morita, Japan's best-known weatherman. He receives the latest facts on the path of Yagi just before the program airs. A video editor prepares a segment using archive pictures of the damage caused by typhoons that hit Tokyo last year.
1年前、東京杉並区では1時間に100ミリを超える雨が降り、浸水や停電が相次ぎました。
1,000 typhoons have drifted across Japan in the last 400 years. In spring and autumn, they are called ame typhoon or rain typhoons. In the summer, when typhoons are characterized by violent winds, they are called kaze typhoon or wind typhoons. Typhoon Yagi mainly affects Tokyo's transportation system. More than 100,000 passengers are stranded because southbound trains cannot leave the city. Peak winds of 200 kilometers per hour sweep across the city. At night, parts of the city will face blackouts as falling trees bring down power lines. "300 domestic flights are cancelled. Haneda Airport, the world's fourth largest, has been temporarily closed. Several thousand passengers take refuge inside as the storm rages on outside." Weatherman Morita prepares himself for his live presentation. As devastating as they are, Morita believes typhoons are part of the natural order, a necessary climatic evil.
実はこの職業柄怒られてしまうんですけども、好きなんですよ結構。で台風っていうのは皆さん嫌がるけれども、台風がなかったら熱帯地方の暖かい空気を北の方に運んでこれないわけですよね。だから台風というのは南の暖かい空気を北の方に持ってきてくれる。あるいは雨もですね、南の方の雨を北の方に持ってきてくれる。そういう恩恵といいますかね、いい面もあるんですよね。もし台風がなかったら世の中はもっと地球はですね、もっと変な風になってますね。バランス取ってくれてるんですよね。晴れてるよね。
The show will soon go out live to viewers across Tokyo. They will look to the 5 o'clock evening news and its veteran weatherman Morita for critical information on where Typhoon Yagi is expected to hit, how strong it will be, and what specific precautions are recommended. Morita broadcasts reports on about 10 storms each season. Today, he can report on the path of Typhoon Yagi with some precision. He hopes this information will help save lives. Only the next morning does the extent of damage done become clear. For the first time in 50 years, the river Tama, which flows through Greater Tokyo, has burst its banks. Important street connections to the hinterland are flooded. Millions of commuters have to stay home. The first victims of this typhoon die in a landslide. On the banks of the river Tama, 30 homeless people need to be rescued by helicopter. The typhoon had taken them by surprise. Back in Numazu, fisherman Harada has been glued to weather reports all night. Now, as the storm clears, he makes his way to the bay to check on his fish. Harada is anxious to see if his prayers to the god of the sea have been answered. As he approaches his underwater enclosures, things seem to be better than he expected. Only a few fish perished in the storm, their gills blocked by debris-ridden water the storm churned up. he sets about repairing the damage, thankful for the outcome.
要は、自然に逆らって仕事してるわけですから、本来でしたら、海からいただいた恵み、旬というものがありますけど、旬の魚を取って、販売するんですけども、それを、周年続けましょうというわけですから、ある意味逆らってますから、こちらが、共存を願い出るような感じですよね。台風も災害も当たり前の中にというような感じですから。
Fisherman Harada has learned to live with the fact that more typhoons will come his way. But like other inhabitants of Pacific coastal regions, he hopes that science will soon be able to forecast typhoons more precisely, so that he can be even better prepared for the next big wind that comes.